Okay, hello, hi everyone. Good morning, good afternoon, good evening. It's an absolute pleasure to be here at the Quality Next conference. So my name is Fede. I'm a subject matter expert in AI and testing. I've been working with Globant for the past 15 years, doing a lot of things from building test automation frameworks to doing AI research and quality assurance assessments. And well, today I'm going to talk about how we can write this new playbook for quality engineers, how we can shift left our prompts and become the architects of the new systems that are being built on top of large language models. This talk is also about discovering a new playbook, how we can tame, how we can drive the attention of these new models toward more deterministic results, and yeah, of course, use them on a daily basis. As you know, large language models are everywhere. They are defining how we shape the software development life cycle, and we as quality engineers have a huge and really good opportunity here, as I mentioned, to become the architects of the solutions. Let's start then with a question. So how do we architect quality on a system that operates under new rules? Generative AI, large language models, and machine learning algorithms are not similar to the problems, let's say, or to the systems that we were used to test, let's say 3-5 years ago. These systems propose to us new rules, right? I have highlighted 3 items, so I can give you a quick overview. Probably you have already experimented them when played around with ChatGPT or the Claude or Gemini models, but by nature, these systems have non-deterministic behavior. And what does this mean? It means that with the same question, we can get 2 complete different but valid answers. It's not just a matter of having a button that I can go and press it and I can expect a pop-up. It's like pressing a button and expecting different shapes of pop-ups, but every solution could be correct, right? How do we orchestrate that? These models also provide unpredictable outputs, right? It's tricky sometimes to get deterministic behaviors. We can ask for test cases, we can ask for test automation code and get the results, get the scripts that we were looking for. Sometimes we can get better answers. We can learn from the output of the models on how to use a certain pattern or how to improve by just doing a quick question. And besides getting those brilliant answers, at some point we can also get the worst hallucinations, right? The model can derail and start showing us results that have nothing to do with what we were expecting at the beginning. And if we're going to build agentic workflows, if we're going to automate tasks using large language models, this is critical. We need to at least make sure that the results are at some point pointing in the right direction of what we want to accomplish. We're also testing on an infinite test surface. You can see these models as a vast array of knowledge with associations between words, but knowledge go from, let's say, quantum physics to coffee shops to Shakespeare novels. So how do we structure the attention of the model to focus exclusively on producing the results that we want? It's not an easy task, and that's why I think we need a playbook that will allow us eventually to shift left our practice and become more proficient, and how we in the future how we start building this system. You may be wondering, okay, so let's get to the playbook. Let's get to the how I do this or that, and how I can leverage my knowledge with the knowledge of the models. But I think that for that to happen, first, we need to ask ourselves a really important question, which is how do these models work internally? It doesn't have to be for us like a black box that we don't know what we're doing, and sometimes by luck we hit the result that we were expecting. And we also don't have to dive deep into know the internals, right? We don't have to know everything that happens inside a transformer model, but we need, for me at least, we need to know the basics, right? We need to know how to drive their attention and how they are composed, so we know what we are doing. And to understand the minds of the transformers, I would like to use an analogy, because for me, believe it or not, the most accurate description of unguided AI was not written by a software engineer in the Silicon Valley 5 years ago. For me, it was written 80 years ago by the great Argentine writer Jorge Luis Borges. You might be wondering what if I have gone crazy or what I'm talking about right now. But yeah, give me a few seconds and let me explain. Borges in 1944 wrote about a man named Ireneo Funes. Funes was a man like any of us, and that one day he fell off a horse and had an accident, went to a coma. And when he woke up, Funes had perfect memory. And what do I mean by perfect memory? That he could remember everything. He could remember every smell, every moment. And as Borges described him, he could remember every fleeting cloud in the sky, every leaf on every tree, every crack on the pavement. He could remember every minute, every shape. And you must be thinking, okay, this was a blessing for him. He was not able to forget anything, so he knew every experience he was exposed to. But for Funes, this gift was also his curse. Funes was so focused on the attention of remember everything that was surrounding him that he was not able to think, he was not able to process this information. He eventually ended up living in the darkness to avoid being overwhelmed by the amount of sensory data that he was exposed in the outside world. There's a narrator in the story also that when he directed his word to Funes, he tried to be as specific and as less abstract as possible to ease the pain of Funes remembering things. And I think that by this point, you're already getting some relationships with large language models and the story that I'm telling you, because models themselves, as I mentioned, have this wide and vast ocean of information, and they work very similar to how Borges was describing the mind of Funes. And what was the problem that this guy has? He was remembering everything, every moment, every single sensation, and that for him had become like a perfect paralysis. He was not able to create concepts. He was not able to abstract. And as Jorge Luis mentioned in his book, he said a wonderful phrase, which is, to think is to forget difference, to generalize, to abstract. And what happens with Funes was the complete opposite. His vast mind of memories for him became perfect paralysis. And that brings us to our nowadays challenges. We were talking about building a playbook. We were talking about how we can shift left our structure. And I mentioned to you that we need to understand the mind behind these models. So we can think that we are working with nowadays with digital versions of Funes. LLMs today remember patterns. They are not able to remember facts. They are able to make connections between words, but they are not able to make connections between concepts. Models nowadays simulate race reasoning. For example, that great question that you got from ChatGPT last week, that you felt that you were talking with another person, well, that's a sophisticated token prediction. The models have become so good at predicting the next word, at elaborating sentences, given the vast information and the knowledge they have been trained, that when you're talking with them, it feels like they are reasoning and you're having a conversation with another human. And the last bullet, and I think this for me is one of the most important ones, is that the models as Funes are paralyzed by possibility of creating things without having guidance. They have all the knowledge in the world. They have all the relationships they were able to build within its training. But without a good prompt, without good guidance, let's say, they are completely useless. So how do we unparalyze them? How we remove them from let's say this curse? Borges in his book didn't find an answer to Funes' problem, and maybe it was not the scope of the short story, but fortunately we have a solution that we can offer. So what's the antidote, right? How we fix this paralysis by knowledge and by a lot of information? And it's not that the LLMs are broken or the technology needs to change. It's not that we need to build a new algorithm on top of this to make it work. It's really simple. And it's about understanding how we can guide the AI's attention. Remember when I was telling the story of Funes that I mentioned about the narrator of the story, that he tried to be as specific and as accurate when he was talking to him? Well, here is the exact same thing. When we are writing our prompts and we are improving them with certain guidelines, that's what we are doing. We are facilitating the neural network its navigation. We're making the attention more direct towards the concepts that we want to hear in its output. And by becoming the creators of these prompts, by finding the antidote to this paralysis, it's how we as quality engineers move from being observers of the output, of measuring the output in terms of, okay, yeah, this has test cases, but it's lacking edge cases or negative scenarios or so on. And we move towards being the architects of the solution. By polishing these prompts, is that we become the filter and we become more efficient. So we get to the playbook. Now we know a little bit how the mind of the models work, and so we can start building on top of that to get good results. And the playbook is not more than a set of rules that we can apply to prompt engineering to work with the attention of the models. And I have called this framework CRISP because, I don't know, it's funny. So you can see it as a CRISP approach to prompt engineering. And CRISP is like an acronym of a few letters that, as I start to explain them, you will see a tight relationship to what you do on your daily basis as quality engineers. It's not that we have to reinvent the wheel or to learn something that feels like a rocket science. It's like a way of abstracting or putting in practice what we already know, what we already master, and see how that eventually help us to get better results. Let's start with a few definitions. Let's start with the first two letters, like context and role. What we are doing here, and I'm going to show you a few examples later, so don't worry. It's with context and role, we are defining the test scenarios and the user personas. Same thing that we do when we define a requirement and when we define test cases. Instructions and specifics. Why are instructions and specifics good practices of prompt engineering? Basically, what we're doing is we're defining requirements and the acceptance criteria. Very similar to what we will do if we're building manual test cases, or if we're building a test automation script. And then the P from prototype, it's a good practice in the sense of providing the prompts golden examples, like canonical examples of what good looks like when we are trying to build code, when we are trying to build tests and we want the test to look a certain way. It's a good practice to share examples of what good looks like. Remember, we're working with this vast surface of knowledge, which are the large language models. And if we ask for a JSON file, if we ask for Gherkin syntax, they know what the words mean and what's the relationship between those words. But in order to produce the structure that we want, it's always a good practice to provide a few examples. Okay, enough theory. Let's see this in practice. Let's start with a simple task. In this scenario, I'm not going to use the framework, but I want just to illustrate a few concepts, so then we move to the framework in practice. Here, what I'm doing is I'm writing a simple prompt, which is write negative test cases for a login page in a markdown table. And I'm using a legacy model, and I'm using a simple model to illustrate things. These are not the state-of-the-art models that probably you are used to. I'm using GPT-2 here. And you can see in the middle, you can see an example on how the attention is distributed, how the model is creating the relationship between words. You can see there are a few lines. The stronger the line, the stronger the relationship. But you can also notice that the attention is all over the place. It's like every word has a relationship with any other word in the prompt. So what's happening internally is that the model doesn't know what to prioritize. The prompt is ambiguous, it's not well defined, it's not well elaborated. So the model is going to work with what it has. And since we are using a legacy model, you can see that the output on the column on the right is completely out of place. It has nothing to do with what we are asking or what we were looking for. Instead of getting test cases, we got HTML code and a description that it does not relate to probably what we were expecting. And this could happen for different reasons. It could happen because it's a legacy model. But if you look at the prompt, it also has some words that could be related eventually with HTML pages, like markdown page, login, table. So maybe that's what's confusing the model. So how do we fix this? How do we create a better approach? Let's start implementing the framework. So the first thing that I'm going to do is then start adding context. So instead of having just the prompt to write negative test cases for a login page, what I'm going to do is I'm going to say, we are testing a login page for a high security banking application. Write negative test cases for a login page. I'm still using GPT-2, but if you look at the GIF in the middle of the screen, you will see how the relationship between security, banking, and the word application creates stronger connections with themselves and also relates to the word testing, test, negative, and cases as well. So the more information we give to the model, the more detailed and the more rich are the relationships between the different words. And that's what eventually helps to produce a more reliable outcome. It's not just that we are adding random words to make these words, to make the model use new words as preference or something like that. It's that truly we are managing how the model focuses on the things that are important to produce the output. Again, GPT-2 is not the state of the art, so its outcome, it's limited. But if you look at the column on the right, you will see that the results are much more aligned to what we were asking in the first place. Now we didn't have an HTML page or HTML elements. We got at least a set of tests, very basic tests for as an output. But this doesn't end here. I mean, we can continue to provide the different elements of the playbook, and we can continue to improve how our prompts look like. Here, what I'm doing is I'm adding a role, and remember that roles are important because it gives like a user persona to the prompt, and it also helps to drive the attention towards what we are looking for. Here I'm doing this example with Cloud Haiku 3.5, which is a more advanced model. And what happens with proprietary models is that we can know the mathematics behind the implementation, but we really don't know how the attention focus internally. But we can eventually predict it. It's easy to do while writing good prompts and evaluating the outcomes. And the thing that I'm adding here is saying, okay, act as a senior cybersecurity analyst specializing in penetration testing. It already knows the context. There's a banking application. Now we add a user persona, and we're still asking for negative test cases. And if you look at the output, it's not just a list of test cases as we got last time, but on this particular scenario, it's like the model transform its output or transform itself into a more let's say, expert in a specific field. The way that it's writing the results to us, the way it's showing us the tokens that it's producing, it has the shape, it has the intention of working as an expert in a specific field. And we have done that just by adding a few descriptions. This not only happens because the models are really good right now and they have been trained and pre-trained on vast amount of question and answer, etc. This type of results, we're getting this type of results because of how we are driving the structure of the prompts as well. But that's not it, right? We can continue to improve and using the playbook to get better results. What I'm doing here is I'm adding instructions and specifics. Remember that a few minutes ago, I mentioned that it was also good to provide examples or to be as specific as possible on how we wanted things, similarly to what the narrator of the story did to Funes' mind to ease his pain. Here is the exact same thing. Instead of telling the model, generate a list of negative test cases, telling the model how many test cases I want, the type of tests, and how they need to be structured. And look how the result looks like with a truly state-of-the-art large language model like Sonnet 4. You get a really well-formatted table with IDs, with the specifics, and it's using the same instructions that we ask about. It's not improvising how the table looks like. It's not improvising the IDs. It's showing you exactly what you were looking for. It's not that the model it's only providing a response, acting as an engineering in cybersecurity, but it's also focusing on delivering like a finished product based on the instructions and the specifics we provided. So what have we been doing with this playbook and with these instructions? we went from a chaotic, a funest mind, which was not able to answer what we were looking for, and doing a sets of easy and real quick modifications, we master the attention, and we leverage their knowledge to produce really deterministic and usable results. Each of these layers of the framework can be, of course, they can be optimized, they can be tweaked and elaborated further in terms of what you want and how you want things. But this set of this structure and this set of instructions already gives you something to start with, something you can start playing around. And it's something also you will see when working with agentic workflows, for example, when working with different enterprise AI platforms as well. And last but not least, let's talk a few seconds about the P from prototype in the CRISP framework. And this is what I was referring when I was talking about providing like this canonical description of what good looks like. This is also a technique called fusion prompting. When you add a specific description on how you want the output, it's not anymore 10 test cases with an ID inside a table, but I want the table to look like this. I want the IDs to be structured in this way. I want expected results to have also this structure. Because remember, the models know associations between words, but they can understand 10 test cases or negative test cases or IDs in different ways. So the closer we get to our prompt to what we expect, then the better. Oh, and here's an example of Gemini 2.5 Pro using the prompts that I have just showed you. Look at the structure and the tables. It's even much better than what we got last time. The IDs have the structure we instructed. The expected results have enough detail to understand what's going on, and yeah, and we even get a description on what the model's reasoning as well. So by doing all this, yeah, we have definitely improved what is the consistency of the output. Okay, so what does this mean? This means that we have found the antidote to what we used to call paralysis. We have successfully guided these Phoenician minds of LLMs towards chaotic errors into more deterministic results. And by practicing this type of framework, by practicing prompt engineering, it's how we can become the ones who architect the quality of the systems that are to come. I think this illustrates the concept that I was talking about. We work with infinite unfiltered memory. We work with models that remember everything, but they don't have the ability to generalize. They are paralyzed without having someone to properly guide them. And by using our prompts, our playbook, we move to guided and focused attention. We force the model to abstract, and we leverage quality. As Borges said, and let me say that one more time, to think is to forget differences, to generalize, to abstract. And that's exactly what we did with our playbook. We helped the models to forget what was not necessary. We create generalizations based on the structure and the guidance that we did, and we create the necessary abstractions to produce the results that we were looking for. And for me, this is what we need to master as quality engineers. As we evolve in our practice, we're going to see more implementations on top of large language models, who are going to be the ones that build the web pages, the mobile applications, the backend services, and the different implementations in between. So we have a huge opportunity here to master these prompts, to use the things that we have learned over the years on how to apply best practices to our tests, to our test plans, let's say, and put them into practice. It's a small step away that will put us in a condition of becoming the real architects and auditors of the system. And we have a fundamental change in our profession, in our hands, right? I think that's what the future departs us. And yeah, there's one idea that for me summarizes the talk, the playbook, and the story. And for me, I think the future of quality in this new era of generative AI is not about finding the wrong answer. It's not about finding the error after we interact with a large language model, but it's about preventing it by designing the perfect thing, the perfect question. So thank you.